far beyond the outer limits of our planetary neighborhood, where the sun appears less like a source of light and more like a distant point lost in darkness. Voyager 1 continues moving into territory no human-made object had ever explored before. It no longer travels between planets or through the familiar architecture of the solar system. Those worlds are now far behind. Ahead lies only interstellar space, an immense region once imagined as empty, silent, and featureless. Communication with Voyager has become an exercise in patience. Signals require many hours to cross the enormous distance separating Earth from the spacecraft. Every command sent outward enters a delay measured not in seconds, but in time that reflects the true scale of the cosmos. Even its replies arrive long after they were spoken. What makes this journey remarkable is that Voyager 1 was never expected to reach this stage. Built during the 1970s, it came from an age when computers possessed only a fraction of modern capability. Engineers designed it for a mission lasting years, not decades. Yet it kept going, surviving far beyond its intended lifetime. Today, more than 15 billion miles from Earth, Voyager travels through a region once believed to be little more than emptiness. But the spacecraft revealed a very different reality. Space between stars is not vacant. It is filled with motion, structure, and invisible activity. There were moments when scientists feared the mission was ending. Signals weakened. Telemetry became irregular. Data sometimes appeared incomplete, raising concerns that the aging probe might finally be falling silent. Then the spacecraft answered again. The response was weak but unmistakable. Voyager was still operating, and by then it had already passed one of the most important boundaries humanity has ever explored, the edge of the heliosphere. This enormous bubble, formed by particles flowing outward from the Sun, marks the extent of solar influence. Scientists once imagined its boundary as a gradual transition. Voyager showed otherwise. The crossing appeared far more dramatic. Conditions changed sharply. Solar particles diminished while the surrounding interstellar environment emerged with its own magnetic patterns and energetic behavior. Beyond that frontier, Voyager detected plasma oscillations, subtle vibrations created by charged particles moving through magnetic fields. These signals revealed that interstellar space was not silent. It carried activity everywhere. As more measurements arrived, researchers noticed shifts in particle density and unusual variations that appeared linked to shockwaves from ancient stellar explosions. Events that happened millions of years ago had left traces still moving through the galaxy. Voyager was not passing through emptiness. It was moving through the history of stars. Magnetic readings added another surprise. The surrounding environment showed organization rather than uniformity. Fields aligned in some regions, then changed abruptly in others. Space seemed divided into invisible zones, each possessing different characteristics. This transformed scientific understanding. Interstellar space behaves less like a void and more like an environment. Plasma flows move like currents. Magnetic fields shift and reconnect. Radiation travels in patterns resembling weather systems spread across enormous distances. Researchers began referring to this behavior as interstellar weather. Meanwhile, Voyager itself faced a different battle: time. After decades in deep space, onboard systems started showing their age. Components weakened. Memory issues appeared. Data quality occasionally suffered. No spacecraft had ever operated this long at such a distance. Engineers attempted delicate recovery procedures from Earth. Commands traveled across billions of kilometers, each step requiring extraordinary precision because even a small error could risk the mission. Slowly, the spacecraft responded. Systems recovered. Instruments stabilized. Data streams improved. With clearer measurements, scientists identified regions of interstellar space that appeared distinct from one another, areas separated by differences in density, temperature, and magnetic behavior. Space was revealing layers. Even now, Voyager continues recording faint signals whose origins remain under investigation. Some scientists attribute them to instrumentation effects, while others consider whether they reflect persistent properties of the interstellar medium itself. Regardless of the explanation, Voyager changed our understanding forever. The cosmos beyond the planets is not empty darkness. It is a dynamic system shaped by magnetic fields, stellar remnants, energetic particles, and processes acting across unimaginable scale. Perhaps the most extraordinary part is this: Voyager never knew it would become this symbol. It was built as an explorer of planets. Instead, it became humanity's first long-term observer of interstellar space. Even as its power gradually fades, the spacecraft continues sending messages home, faint transmissions crossing billions of miles, carrying information from a region once hidden beyond experience. And with every signal, it reminds us of something profound. The universe is not silent. The darkness is not empty. And beyond every horizon humanity reaches, another one still waits. Beyond Voyager 1, the journey enters a stage even mission planners never expected to witness. The spacecraft is now operating in a region where every remaining watt of power matters. Its energy comes from radioisotope generators slowly losing output year after year. There are no refueling missions waiting ahead. No maintenance crews. No rescue. Only careful decisions made on Earth to keep the last active systems alive for as long as possible. To preserve power, engineers have gradually shut down instruments over time. Each shutdown is permanent. Every system turned off represents a choice between continuing the mission a little longer or losing communication entirely. Voyager is not failing suddenly. It is slowly giving away pieces of itself so the journey can continue. And yet, despite this gradual decline, it still sends information from farther away than any human machine ever has. The distance itself creates extraordinary challenges. Voyager's signal reaches Earth with less power than many everyday devices produce. By the time the transmission arrives, it is unimaginably weak, spread across billions of kilometers of space. Detecting it requires giant radio antennas and sensitive systems capable of hearing what is almost a whisper against the background noise of the universe. Still, Earth listens. The messages arriving from Voyager are not images or dramatic discoveries every day. Most are streams of measurements, temperatures, magnetic readings, particle counts. Small pieces of data that seem ordinary until combined together. Because hidden inside those numbers is a map of a place humanity has never visited before. One of the most important discoveries concerns cosmic rays. Beyond the heliosphere, Voyager detected a sharp increase in these high-energy particles arriving from outside the solar system. Inside the Sun's protective bubble, many of them are partially blocked. Outside it, their presence becomes far stronger. This confirmed something scientists had long suspected. The heliosphere is not merely an edge. It acts like a shield. It protects the solar system from part of the radiation moving through interstellar space. Crossing beyond it revealed just how active the surrounding galactic environment truly is. Voyager also showed that the boundary itself is not fixed. It shifts and responds to changing solar conditions. The frontier between solar influence and interstellar space behaves more like a moving surface than a permanent wall. That realization changed the way researchers viewed our place in the galaxy. The solar system is not isolated. It moves through interstellar space while carrying its own magnetic bubble around the Sun. Together, they travel through the Milky Way like a ship moving through an ocean. And Voyager has become the observer standing outside the vessel for the first time. What lies ahead remains uncertain. Eventually, power levels will fall too low. Instruments will shut down one by one. Communication systems will stop responding. A final transmission will leave the spacecraft and travel back toward Earth. Then silence. But Voyager itself will continue. Long after its voice disappears, it will keep moving through the galaxy for thousands, even millions of years. The spacecraft will drift among stars carrying the golden record, a collection of sounds, images, music, and messages placed aboard as a greeting from Earth. A time capsule from humanity. It contains voices, greetings in many languages, music from different cultures, and traces of a civilization that launched a machine into the dark simply because it wanted to know what was there. Perhaps one day no one will remember the engineers who built it. Perhaps the spacecraft will never be found. But Voyager will still travel. A silent artifact crossing interstellar space long after modern cities are gone, long after generations have passed, carrying evidence that a small world once looked upward and chose exploration over fear. And maybe that is Voyager 1's greatest discovery. Not the plasma waves. Not the magnetic fields. Not even interstellar space itself. But proof that curiosity can outlive the limits of its creators and continue moving